All right, this is lesson 11-4. It's about volumes of prisms and cylinders. Running the camera today we have Joey. And I've also secured three model students, David, Isaac, and Luke. So let's go to page 717. I'd like to point out some things in your book there. One interesting thing at the bottom of the page, they took two stacks of paper and they just sort of obliqued one of them, made it slanted instead. Their point being that it's still the same high, it still has the same volume, and oblique cylinders' volumes must be found using not the edge, but the straight up height. And then the volume should match. Turn ahead, model student Luke, and can you find somewhere in a beige box a formula for the volume of a prism?
The volume of a prism is the product of the area of the base and the height of the prism.
So I suppose you're recommending that students put something like this on their card.
Oh, of course.
Are you recommending the teacher gets a good marker?
I'm not sure if he wants to.
Volume is equal to capital BH. Remind the people, Isaac, if you know, do you know what that capital B stands for?
Base. Perimeter of base.
Area of base.
Area
of the base. I'll just put that on here. Maybe you want to add that, Isaac, just in case you don't.
I think I have that on my card.
That's a lie.
I do.
That's the base's area.
I have that on my card.
Excellent, excellent. And you'll never forget it. Or you may forget it, but it's there,
It's on my
right?
card.
That's a model student, ready for any contingency. Show the people his card. All right. I'm going to let Dave help me here, Dave. Dave, this is a prism.
Yes, it is.
And the boys here, they talked about the area of the base. Which side of that is the base?
I mean, there's three possible bases.
He's so right. With a prism, you could pick any side for the base because the base is any face that has a matching side on the other end. So you could go wall, wall, or wall. Which do you choose, David?
Let's go the wall.
David's choosing wall. If you do that, Dave, choosing the 3x3 you chose,
Yeah.
what would you put in here for area of the base?
9.
Me too, me too. And what would you put for the height?
6.
Now, a common novice amateur would look at that and say the height was 3, but they're just using ordinary world nomenclature for height, not math talk, right?
Correct.
You and me would get it.
Yeah.
Some of them too. Luke,
Yes.
what's the answer here?
54.
So like if these were inches,
Yeah.
what would you put for the label?
Inches cubed.
Cube, Luke, all last couple of weeks we've been saying inches squared. Why did you bump it up today? Why did you bump it up to cube?
Because it's a 3D image.
It's a 3D image. We had 3D images yesterday.
Well, those were like those were the perimeter. This is like the entire thing, on the inside.
What word's he looking for?
Volume.
Bam for the Isaac there.
Yeah.
Volume is like capacity to fit inside. Before we were just talking about surface or how much it takes to cover, like say if you would paint it or paper it or something. So good job, Isaac. We have bumped up our answers to cubes now. Well, that wasn't too hard. Tell me what this next, well, it says right on it there, Isaac. It's a
Cylinder.
Can you find somewhere, Isaac, in this chapter a formula for the volume of a cylinder?
volume equals base times height, or volume equals pi times radius squared times height.
So you're saying this still works, but that's the same as that?
Yeah.
Can any one of my model students explain why that and that are the same? Model student David Burns.
Because pi times radius squared is how you get the base area.
Nicely said. This base is a circle, and the formula for area of a circle, he knows to be pi r squared, so we replace that with that. Very good. So we could just fill this in with pi times, what is the rate? 3? 12?
Yep.
And you guys are saying inches cubed again?
Yeah.
Yes.
All right, all right. I think this is an actual problem of like number 1 or 2 or something. So we might be interested in knowing the answer, Luke.
Do you want it in terms of pi?
No.
No. Okay. Pi times 3 squared equals that times 12 equals 339.3.
He's thinking 339.3 cubic inches. All right, now for the ultimate. We have another prism. Prisms aren't always just boxes. They can take quite a few shapes. Would any of these 3 gentlemen care to describe what it takes to be a prism?
You have to have one face that matches the other on the opposite side.
He's right. If one of the faces matches the face on the opposite side and all the faces are flat, you've got a prism. So I guess that means same formula. But let's watch how this plays out. We've got to do the area of the base. Now, Isaac, you know it's important to be careful with this base and your capital B and your little b in that whole game. You got your base and you got your base. So, what should I do?
Find the area of the base.
Yeah, we got to find the area of the base. Now, Dave is kind of our base selection expert. Do you want him to select the base, or do you want to just take care of it?
Oh, I'll take care of
He'll take it. He'll take it. Which one?
it. The triangle.
The triangle is the base?
Yes.
No other options, right?
Yes.
It's got to be, right? So can you help me figure out, by the way, that's a little hash mark there. You can help me figure out the area of the base?
Sure.
He says he can do it. Let's do it.
Okay. It's 4.5.
He says it's 4.5. Tell him how you did it.
Base times height divided by 2.
Now that's going to confuse some people, isn't it, Isaac?
Yes.
Because that's a base and that's a base and then that's a height and that, is that the same height as that height?
No, I'm confused. No.
All right. So I think you did 1/2 3 times 3 here for your 4.5. Right?
Yeah, that's what I did.
I'm with you on that. But what is that H?
That is the height of the triangle.
Okay, that's just looking at this little triangle face. So you're saying that's little b, h, ding, ding, there, right?
Yeah.
What's that one?
That's the 5.
Ah. Alright. So you're saying we should get maybe like a 22.5. Let's take a peek at number 11. What kind of label should we put on it?
Feet cubed.
Feet cubed.
Or you
Like
could take that
so.
times 12 for inches cubed. If you wanted to.
Just trying to show off now.
All right. I might have to erase that part out. Sorry. It's like, say, if you have a cubic foot, and you start putting little cubic, it's more than 12 will fit in there.
36.
More than 36, because you got
72.
like 12 rows of 12 and 12, like, that's a whole
144.
That's even more than that. Just,
Oh my
just
gosh.
tell them.
That was wrong, I'm sorry.
Backing down, backing down. I think we've given them enough that, wait, there's always the part of the lesson where you have to think on your own. So let's take a look at number 3. You want to read that there, Luke?
I will. Is the figure at the right a composite space?
A composite space figure, you guys know anything about the word composite? Like, what do you think this is, a composite space figure?
Is
think
made
it
of
is.
composite?
Where's Fields?
Guys, don't make this a joke.
Riley?
Definition of composite space figure is a three-dimensional figure that is a combination of two or more similar figures.
Where'd you get that?
Oh, it's right here.
Oh, go.
Three-dimensional.
Well, with that in mind, is this one of them?
Yes,
Yes.
that is a composite space figure.
A couple of things put together?
Yeah.
Oh, yeah.
Like what are the
It's a
two
cylinder
things?
and a cone.
and a cone.
These guys are good. These guys are gifted. Well, I select these 3 special people. Special people. All right, let's go on to number 4 then. How are the formulas for the volume of a prism and the volume of a cylinder alike? Well,
It's the same thing.
they're identical, Isaac says. So Isaac is kind of saying, how are they different?
They
Not-
aren't.
Not at all?
The way that you find the base is area is different.
All right.
Yeah.
The formulas start out the same, but the actual fleshing out of the area of the base part will be different. Well said by the models. Is there anything else left there, Luke, on the practice area up there?
Number 5.
Number 5. Number 5. Can you read that, Isaac?
How is the volume of a rectangular prism with base 2 meters by 3 meters and height 4 meters related to the volume of a rectangular prism with base 3 meters by 4 meters and height of 2 meters? Explain.
A little attitude in there. Okay. Did it totally go over your head, or does it just seem
Oh,
too easy?
is
I'm
it
not
supposed
sure
to
where your
solve this?
attitude is coming from. Were
Um,
you insulted because it's too easy or too hard?
I think Luke needs another one.
I see what you're doing there.
I get it.
Swing to Dave. We don't need 3.
They're the same areas. The two
Volumes, you mean?
volumes, yeah, that's what I meant.
Okay, I'm with you. So the answers will be the same. And then for the explained part, what do you think that?
Because I did the math.
Same numbers.
Because 2 times 3 is 6, times 4 is 24. And 2 times 3 is 6 times 2. 3 times 4 is 12. Times 2 is 24.
All right. I would like to explain that the reason Dave spotted this first is because he is a master of seeing various base options. On this original problem, he saw that you could call this 6 by 3 down here the base and go with 3 as the height. Or as he chose, you could call the 3 by 3 the base and go with the 6 as the height. It's his gift for seeing it different ways that made him see the answer to this problem. And he understands it has to give it the same answer because it's the same prism. And if you started getting different answers by doing things a different way, then those plans don't overlap and they aren't part of the great unified plan of order. Every plan has to overlap and give you the same answer when they overlap. Else, what kind of world would this be? that's the end of lesson 11-4. That will be due numbers 1 through 20. We'll check it on Tuesday. Reminder, we're going to check 11-2 and 11-3 on Monday. Just a little long-range forecast here. We're going to be checking 11-5 on Wednesday next. And then on next Friday, we're going to be checking 11-6, 1 to 22. And I'm just going to give a sneak peek of, this won't be next Wednesday, but this will be the following Wednesday. I got my little card ready. Did they see that? Oh.
No, it's chapter 11, 10 pack.
It's a 10-pack.
That,
10 pages.
Like 1, 2,
if you wanted to get started, I mean, that next week we'll be working on that 10 pack. So it's available in case you're planning to be gone or something. You can get a jump start on it. Goodbye. Thank you, Joey.